Hello everyone, welcome back. Let's take a look at the emitter creation now. So I'm going to dive inside, and this is the geometry I used. And I'm going to create a bound node just to get a box the same size. And the idea is you create a box or whatever geometry you have, and then we fill that with points. So I'm going to use points from volume node, and this is going to fill it with grid nicely distributed points, okay, over a grid. And then I'm gonna use a point VOP and add noise to this. Let's create that and create the noise, and I'm gonna plug that there, and let's play with the settings a bit. It's too much. I'm gonna copy this guy, paste relative reference for both of these, 0.5. Okay, let's try set this to 2, maybe 1, and this guy. Cool, something like that, just to get randomization there. And then I'm gonna use a blast node and delete anything that is below, that is not white, basically. 0.5, and delete points. Add cd.x to check the red channel. And let's see. That should do it. Okay. Yeah, the range is very low. Let's let me increase this to 3. So let's replace restore the color to see them all. Okay, that's a lot of points, so I'm gonna set this to 0.25. Okay, and then we're gonna use a particle fluid surface, a VDB from particle fluid, and this node basically converts a set of points into a mesh. It's basically the same node that we use for meshing, which we haven't talked about yet, but we'll cover that later. And you can see it fills this. It made an SDF right now. It's not a geometry yet. And I'm gonna lower the influence scale to droplet scale 0.5, and let's lower the particle separation. Something like that. We can delete more points to create more gaps, and that's pretty much the idea. And then we'll convert this into a geometry using VDB convert, and I'm going to convert this into polygons and increase the adaptivity to get something like this. And then that's how this geometry was created. It's just different pattern and noise. And then we're gonna fill this with points using the flip source. So it takes this geometry and converts it into an SDF again and fills it with points, and that's the particle separation that decides the number of points. And that's pretty much it. This new node, this is actually a new node in Houdini 17. We have an option to add velocity, so I'm gonna set this to 20, and this will simply push the fluid in this direction. That's all. Now, a very nice way to visualize this is using the visualize node in Houdini, and I'm gonna isolate the points only. So here I'm going to isolate the group particle. If we middle click, you see it has point groups particle, and that's where the points are, and the rest is an SDF. So if we delete not selected, we have the points now, and we can use a visualize node. And instead of color, I'm going to visualize, we're going to use a vector. Sorry, we're going to use a marker, and then here instead of text we're going to use a vector, and we're going to change this, instead of off we're going to turn it on. Okay, and this will show us a direction for these, for the velocity of these guys. Now obviously it's showing the position vector, and we're going to change this to V. Okay, right now it's showing all the points with this arrow method, and it's too much to visualize. If you have tons of points, only 5,000, it's like this. If you have a lot of points, it can actually crash your Houdini session. And what I'm going to do is I'm going to write a simple wrangle node to keep only 10% or 1% of the points. So I'm going to do this: if rand at pt is less than 0.1, and this will keep 10% of the points. Remove 0.0 at pt_num, and that's gonna generate a random number that goes between 0 and 1. If this number is less than 0.1, which means 90% of the points will be affected, we'll have this condition true. We want to remove the point that is coming from the first input, and that's number 0, index number 0, and the point number is at pt_num, and that's what's available in this. And let's see, actually we need to change this to 0.9, sorry, and that's 90%. We have 5 and we have 500 here, so we can visualize them better now. Okay, so that's our source. And let's go back to the flip, and I want to change the domain to include all of this, so that when it collides it has more room. And I mean, you can tweak this, there's nothing right or wrong about it. I'm going to set this to 40, 125 here, and this is 19 and 10, and I'm trying to match the previous settings I had. Okay, let's do a test. Let's hit play. And right now it's continuously emitting points, and we don't want to do that. We don't want this to be forever emitting. We just want a burst of points, and then we want it to stop and see how those behave. And so I'm gonna animate the activation to be only active for 15 frames or 14 frames. Anything after that, the emission is going to stop, and this will give us the enough amount of fluid to work with. So let's wait for this. And that's our first splash geometry. Now let's tweak the color for the particle visualizer. We're using velocity. Let's change this from 0 to 60, maybe 40, so we get to see everything here. Let's hit play. Cool. Okay, so I'm not gonna change anything. I'm going to increase the resolution. I'm going to increase the resolution here by lowering the particle separation, and I'm gonna hit play, let this cache, and then we'll continue in the next video. Thank you guys for watching, and see you in a bit.